Hi, welcome to the Chico Math, the differential equation problem solving session. So we did a lot of problem for the first order differential equation. And then now, before we go to the second order differential equation, let's try to take a look at this Wronskian type of the concept here. All right, so here is the problem we try to solve. So, okay, so this problem tells us that suppose we know the Wronskian is try to determine that whether the solution set for the differential equation are independent or not, right? So now let's say that here, suppose the Wronskian for the function, the solution f and g is e to the negative 1/2 t. And now I have another two function u and v. They both are linear function for the f and the g's here. So now we want to find the Wronskian for the w, u, and the v, and so also take the derivative of that. So before we do that, of course, we can do the hard way. What I mean the hard way is like we can just plug into the like here. So we can do this, like we said, the Wronskian of the u and the v. Now we can just find the determinant, right? So we can just find the determinant. The u is 2f minus g, and this is f plus 2g, and then take the derivative 2f prime minus g prime, f prime plus 2g prime. All right, and then do a lot of algebra and to solve it, right? And then try to substitute to solve to the, use the Wronskian for the FG to solve it. Yeah, we can do that. That will be a lot kind of the algebra involved, and or we can use these properties here. We know the u and the v's, right? So if you put into a matrix form, u and v is equal to, because they are the linear combination of the f and the g, you can see that is the matrix of the f and the g and times a matrix here. So this is 2f minus g. So this is two negative ones, right? Rows column. And then this is a 2f plus 2g. So it's 1 and 2 here, right? So this will be just a simple fact, the matrix multiplication. And then now we know we can physically prove it, but I'm not going to do that. So we know the Wronskian UV here will be equal to the Wronskian for the f of g and multiply the determinant of this matrix here. All right. So now in here, I can say that this determinant will just be phi, right? So this will be phi. So I know that the Wronskian of the u and the v is phi times. Then because the problem given us the Wronskian of the f of g is e to the negative 1/2 t. So this will be phi e to the negative 1/2 t. Right, so it's pretty simple, right? So remember that, right? So if the UV, you can write it to a simple matrix multiplications, then the Wronskian of the UV will be equal to the Wronskian of the FG times the determinant. As you can see, I change here is the determinant. All right, so then the question asks, what is the determinant? Take the derivative of the UV, then will just be a pretty easy. It's a negative phi over 2 e to the negative 1/2 t. Okay, so this will be a pretty easy problem. So the key things here is this concept, correct? So the key things is this concept is here. If you can write that into a matrix, and then the Wronskian will be equal to the Wronskian of the matrix FG times the determinant. All right, I hope that this one, will help you for you when you try to do some homework. And okay, so nice talk to you. Guess I'll talk to you in the next time. So, all right, have a good day. Bye.